Good morning. Can you hear me who is on the Zoom now? Yep. Okay, perfect. So welcome to the continuation of our great conference. And today we will start session connecting with ICT applications in education. I will moderate this session, and I really glad to introduce the first speaker, who is Yaroslav Ponzel from National University of Life and Environmental Sciences of Ukraine. And his talk will be managing students' engagement during the educational process using MorphCast AI tool. Okay, the floor is yours, Yaroslav. You can start.
Thank you. Dear participants of the conference, the research topic I would like to present today in managing student engagement during the education process using the MorphCast AI tool. Modern technologies, is particular artificial intelligence tools, are becoming increasingly important for optimizing and improving the quality of the educational process, as well as ensuring effective interaction between participants in the educational process. Emotional are another important factor that can significantly affect student performance. The purpose of the article is to identify indicators for evaluating artificial intelligence-based emotion recognition tools to determine the importance of each of them for both teachers and students, and to explore the capabilities of the MorphCast tool for analyzing students' attention and engagement in the learning process. The pedagogical experiment on the implementation of facial emotional recognition of students listed during the 2023-2024 academic year at the National University of Life and Environmental Sciences of Ukraine. To evaluate artificial intelligence-based emotion recognition tools, 70 teachers and 39 students were surveyed on certain assessments indicator after a series of lecture classes. Using MorphCast 7 main emotion, neural, happy, surprise, sad, angry, fear, disgust, representing the facial expressions of students during an online lecture, were obtained based on which a report on the level of attention and engagement was generated. This measurement is carried out during a synchronous or synchronous interaction of participants in the educational process. The measurement process consists of 3 stages: demonstration of educational material, recognition of student emotions, and generation of report of emotional state. While viewing the education content, the student provides access to personal data from the video camera. This allows the students' facial expressions to be read while viewing educational material and their emotions to be recognized. At the same time, the teacher has access to real-time data on student engagement, attention span, and mood. The data obtained during the meeting allows you to generate a report on the emotional state of student during the meeting. To evaluate artificial intelligence-based emotion recognition tools were surveyed on certain evaluation indicators after selection. A questionnaire was developed in which teacher and students were asked to assess the importance of each of the indicators. Detecting the emotions, the first one, contextual relevance, easy of use, accessibility of metrics, confidentiality and privacy of data, integration with other tools, integrated feedback from students, and ability to analyze the dynamics of the emotional state. Experts assessed the significance of the developed indicators by using them a rank number. The factor with the highest rating was assigned rank 1. The level of consistency of experts' opinions was determined using the concordance coefficient. Concordance coefficient indicate a high degree of consistency in the opinions of experts. The statistical significance of the concordance coefficient was checked by the Pearson correlation criterion. The students note that relevance of the context 0.23, easy of use 0.20, and accuracy of emotion detection 0.19 as the most important indicators when evaluating such tools. According to the teachers, following the indicators are the accuracy of emotion detection 0.22, the ability to analyze the dynamics of emotional state 0.19, and relevance to the context 0.18, and the availability of metrics and reports 0.16. An example of determining students' emotion during an online lecture on possibilities of data processing in Microsoft Excel, and after the class is shown on the slide. It is important to note that these are only general trends, as the emotional state of each student during an online class depends on their personal qualities and relevant circumstances. Nevertheless, the indicators of the level and engagement and attention during the demonstration of different types of content were compared. Table shows that average value of these indicators during the lecture fragments that were accompanied by demonstration of simple slides explained the material, screen content during the solution of practical task, video content, as well as during polls and discussions. The level of students' attention increases significantly during the demonstration of the practical task solution and during the polls and discussions. Demonstration in online screenshot or videocast attracts the least attention of students. And conclusion, in today's environment, stressful situation or emotional fatigue can distract students and complicate the learning process, leading to navigate negative consequences such as apathy, low emotional and satisfaction. Paying attention to and supporting students' emotional states will help to create a more effective learning environment for them, taking into account different types of learning activities and delivery of different types of educational content. A positive emotional state has a positive impact on students' performance and the microclimate within the group and the stream as whole. Based on the result of study, we recommend the teacher use interactive teaching methods when conducting online classes, organize polls and discussion during various types of learning activities, in particular organize discussion during lecture in synchronous mode, as well as use a variety of visual materials, change the pace of speech, take breaks, conduct polls to find out whether students understand the material and are interested. Thank you for your attention and interest for our research.
Okay, thank you so much. I forgot to introduce myself. My name is Tetiana Zakharchenko, and I work I'm director of computer science program in Ukrainian Catholic University. Do you have any questions? Okay.
Thank you very much for your nice presentation. Could you please go back to your conclusion slides?
Yes.
to have any factual support for the conclusions listed here. For example, the first bullet says paying attention to and supporting students' emotional states. Well, how create a more effective learning environment for them? How could you measure the support of emotional states, and how to measure the impact on more effective learning?
It's all measures in real time. During, you can see this in example, we can in real time measure different fields and of different students, and we can see, for example, during our lecture, if it's if our students not really paying attention to our slides, and we, for example, can try another example of our lecture. Maybe we can try some polls, or we can start some discussion, and it's really depends from teacher in which way we can improve our process. Maybe if it's not really teacher with good experience, it can be a bad experience with its programs. So you could try, and after that, I think after a couple attempt, you will have some success with these tools.
Could you please elaborate what is measured in these curves? I can't really see it. I can't.
You cannot see. Okay.
No, just explain.
Yeah, of course.
What do these red and green curve mean?
Here we have some statistics of students with his name, for example, Oleg, Rostislav, etc. We can see which facet is really recognized, because maybe some student it's in I don't know, in the shadows or in a sunny day, so it's his camera is not recognized as well.
If you, I'm sorry
yeah.
for interrupting you. I'm asking about this curve. Where is the sunny day in the curve?
In this curve, it's a real-time measurement that we received after our lesson, when we can see, for example, if during some specific time, we can see, for example, if attention of our student is high enough or not, when was raise of attention, when wasn't raise of attention, etc.
This leads me to the question, how do you measure attention based on emotion recognition?
It's black box logic of this tool. It depends from algorithm.
Okay. So let us go back to the measurement of impact. In an educational experiment, you can measure any educational impact by comparing an experimental group result and control group result. Did you do that?
Can you repeat, please?
When you do an experiment in education, you have two groups.
Yeah.
The first is going through the traditional methodology of teaching and learning without measuring emotions in the context.
Yeah.
An experimental group would be going through emotion measurement, and there are different impacts on the learning process and the learning results. Did you do this comparison between these two groups?
It's comparing between these two groups. We can measure by satisfaction of the student, because before
I do know what we could measure. Yeah. I did ask you if you did this comparison.
Yeah, in our article we give some data that our student is more satisfied with using these tools than without these tools.
So you get this information via the questionnaires? You ask students to fill out the form. And you ask them directly, are you satisfied or are you not satisfied?
Yeah, we have this data, and we have some data about what is expecting from student from this tool, or they expecting improvement, some feedback from teacher, some better interaction with student, with teacher, etc.
Okay, thank you. Could you please go to a slide with the measurement results, with the tables, with the statistical results?
We have two tables, one.
Yeah, anyone.
Okay, this one?
No, the previous one.
Previous one, okay. Yeah.
Okay.
Yes.
Okay, what do these numbers mean?
Its numbers mean, for example, A1, A2, A3, it's our indicators of, for example, accuracy of emotion detection, contextual, easy of use, etc. And
could you please, no, sorry again for interrupting you. Could you please show us the accuracy of emotion detection? The figures on the accuracy.
Accuracy of emotion detection. Okay, it's A1 on this table. It's was ranked by student of is it importance for important factor for students or not, and we take the sum of this rank and make some measurement.
Sorry, this is not about the accuracy of emotion recognition. There was a number of something like 0.22 in terms of the accuracy of detecting an emotion. Is it a good accuracy or bad accuracy? 0.22 out of how many? Of one?
0.22, it's by teacher, ranked by teacher. It's not good or not, it's not bad. It's was decided by teachers. Is it important for the, I don't know, for the lecture or not? It was decided by.
Could you trust the result having such a low accuracy? 0.22 out of 1.
I don't. It's not the measurement of accuracy. It's importance of the measurement of accuracy for the group.
Okay, thank you very much. I'm done.
Thank you for the interesting study. But my question is, your main purpose is to measure student satisfaction and attention. Isn't that purpose of educational process not just to satisfy students and make them happy?
Not only about happiness. Our research also for improving some attention, some interaction with student, because when a student has some.
This is about entertaining students, yeah. Interaction.
Yeah. Of course, because
that's my question. Is this the main purpose of the educational process? To entertain students, make them happy?
It's additional availability to give some knowledge for students, because when students didn't pay attention to our lectures, so it's not very good for his process, their process.
I have some questions too. Am I right? Like, that students knew that you would measure
Yeah,
attention.
We have agreements.
You know, when we intervene and students knew that we will measure their attention, they could be more attentive just because they are, you know, so okay, my question.
Is it possible? Maybe.
You need control group somewhere, or a blind experiment, for example, that Or more,
Okay.
okay. And my question about your sample, you mentioned that you have 39 students and 17 teachers.
Yeah.
So the ratio between teachers and students are like is high. So my question, why like so many teachers?
Yeah.
That's the first question. And in your abstract, you mentioned that you took like verbal contest, like in consent. Yeah. Can you elaborate a little bit more about that? So you just ask students, don't you mind? Or it's like somewhere recording? Because like emotion recognition is a really important topic nowadays, like with AI tools. Thank you.
Okay. Why so many teachers? Because it was a test from some specific group of students of the specific year of education, and there was some different teachers from different subjects and their assistants. So that's why we have a lot of teachers here and not so a lot students. And also when
Excuse
we
me,
have...
what was the ratio of teacher to student, like in the process when synchronize meeting?
Meeting was with, for example, two teachers, one teacher, one assistant, and a group of students.
How many students?
Group, it's like, I don't know, sometimes 10, 15, 20, depending from attendances.
Yeah, but the attention could be different for small group, large group. You know, because
it's
teachers see better students if you have less. So
we pay attention more for in this research for statistics from our tools, but still 10, 15 students, it's a lot when you try to speak some lecture topics. So it's not very easy to interact with each one.
Thank you for recalling about statistics. I have a statistical question for you.
Yeah.
Do you think the sample of subject is representative for your experiment?
Can you say in the another word your question, please?
Subjects are those people or entities who participate in your experiment. Representativity means that the number of subjects represents all the deviation which might come from the real world.
Okay, and
more or less in different words.
Sorry, I don't have an answer for this question, I think.
Okay, so maybe you can finish with this verbal content.
In this case, we trying to give some another kind of lecture content, for example, pulse video or etc. Maybe stop, read some lecture and try to talk with student, give some questions, etc.
I have also one question. Thank you for your presentation. And I would like to ask you about number of involved students. So if, for example, one student lose attention to topic of lecture, what can be reaction? So do you have some threshold? After that, you can react on them. Only one student can lose attention, or maybe half of group. So in this case, it's only subjective opinion to lecture, or maybe some another approach.
Okay. I think it's not really effective when we pay attention for one student, because our students located to Ukraine in different areas. So it's could be really different reason that student cannot interact effectively with our lecture. So in case if we trying to stop our presentation for one student, it wouldn't be really effective. So we try to think about more group of students.
But you haven't some critical mass, for example, 30% or 50% of group.
It depends from teacher, it depends from lecture, and it depends from content. So we don't have some accurate score for this measurements. It depends only for teacher.
Thank you.
Yeah, thank you.
Thank you for your presentation. And I also got a question. I've never used Morphocast AI. So I just wonder, this is a real-time metrics of students' emotions, right?
Yeah.
However, you mentioned that you analyze the results after the lecture. So if I open these two apps on my laptop, but I analyze the data afterwards, how can I respond to their emotions right when I see that they lose attention or they are they experiencing fear or whatever else?
You have two statistics from this tool. One in real time. It looks like this. So you can see, is it, for example, a lot of students pay attention or not, but after that you could see some detail attention. Different statistic during by different time, so you can analyze your effectiveness. It's free use app, so I think maybe in paid app you could receive some more effective statistic, etc.
Thank you. And a follow-up question on that. I'm a lecturer and I'm giving a class to my students, and I have a presentation opened, let's say in Zoom, and we are interacting with the content, and I'm organizing some interactive questions, and I'm really involved in the conversation with them, and then I should also pay attention to this real metrics, right?
If you wanna, yeah, you could, but I don't know, maybe in this exact case, it will be not really effective, because maybe if student just in this case trying to give response for some answers, they wouldn't pay attention to the screen or video camera. So you already know that all students give some attention to your questionnaire. If you receive then a lot of answer for your pool.
Okay, thank you. And in your opinion, what are the limitations of this study and the use of Morphocast AI? Thank you.
Limitation by teachers or limitation by students, or I know it's not, it's really suitable for our case when we had 30 students. So I think it's will be yeah, we measurement it's for more students, 60, etc., but it's not in this article. So I think it will be suitable in different cases, but it depends from these tools, and maybe these tools will have some improvements in future. So availability of these tools will be, for example, different after half year.
Okay, thank you so much.
Yes,
Don't have time more for this presentation. Thank you.
sufficient enough.
Okay. So our next speaker is Tatiana Holovatenko from Kazan Kharkiv National Universities with the talk Formation of Social and Civic Competence of Bakers of Preschool Education During Distance Learning in Conditions of War.
Greetings, everyone. We'll continue our discussion on the importance of emotions and the development of ICT and education. This talk will be the presentation of joint research by Boris Hrynchenko Kyiv Metropolitan University and Kazan Kharkiv National University. Next slide. The idea of this study was born after the analysis of current social challenges. A lot of our students are displaced, and this study was framed in the context of blended learning, organized at Boris Hrynchenko Kyiv University. And there are a lot of military actions on the territory of our country, and well, I guess we can't hide an elephant in the room. And war influences everyone, especially students who have a lot of traumatic experiences in their lives. And of course, they are under threat to mental and physical health. However, in this context, I wanted to mention that the target audience of our study was preschool education student teachers, and they work with preschoolers who are really vulnerable to everything going on around them connected to war. And we also see that we need to develop active social and civic engagement, and a lot of people are really active in terms of this. However, there's also social anemia when people are just confused and frustrated about things going on around, and we need to address this issue. And a very sensitive gap for addressing it is in preschool age, when we show little kids how to do that. So the idea of our research is to cascade the knowledge, to teach student teachers how to develop social and civic competence of preschoolers. And in this cascading knowledge, we will raise a new generation of Ukrainians. And we should also state that the development of social and civic competence is under-researched. And even though our target audience is really sensitive in terms of developing this competence, there is lack of research on that. Two major ideas that we occurred while analyzing the theoretical grounding. We realized that it's critically important to start psychological and pedagogical support at early stages of child development, and this is the sensitive window of chance for developing students. And the next one, that prolonged stress in children leads to mental health challenges. So if we teach kids how to work in the social environment, we'll develop their social skills and will promote their resilience. And at the same time, this will be win-win situation, because we'll develop social and civic competence for them. And in terms of the theoretical grounding and how we frame this study, we found 4 key themes. And the first one was foundations in preschool education, as the target audience was preschool student teachers. Children are sensitive to teachers' models. That is why it's very important to frame these models and to show these models for student teachers. Next idea, the teachers are to model social interactions with students. So we designed our experiment so that our students can learn how to design these interventions and interactions for little kids, and after that model them in real-time situations in real life. And by developing social and civic competence, will foster students' resilience, and in this way will also address the challenge of wartime Ukraine. And the next theme is ICT in preschool training. And as this study was set in blended mode, we paid attention to minding the screen time both for students and teaching how to mind the screen time for little kids. And also teaching digital literacy to preschoolers and how to teach it in terms of current settings in preschool institutions. The next theme was early development of social competence, and we found out that we should model social and moral competence through early experiences, through play, through using various games and interactive activities. And also, we found out that emotional, social, and moral competence is shaped by these activities. So we designed a course for students, which we'll talk in more details a little later. And within this course, students acquired necessary tools to go to preschool institutions and model them for kids. And the fourth theme was teachers' role in competence building. We found out that authoritarian teaching styles hinder the development of social competence. That is why we designed our course in terms of peer-to-peer communication and interaction. And also, we found that teachers need skills to support students through trauma and life challenges. And in this context, we designed the course based on topics of social emotional learning and trauma-informed education. So the purpose of our study was to experimentally verify the effective use of ICT to develop the professional skills of future preschool teachers, to form the foundations of social and civic competence for toddlers and preschoolers. And the methodology we used was pre-test intervention, post-test methodology. And we found, based on the theoretical grounding, we found two main objectives for the pre-test: to assess the level of pre-service preschool teachers' self-efficacy in cultivating the foundations of social and civic competence in toddlers. And the second part was to identify which ICT tools students typically use in distance and blended learning, so that we can expose them to other tools they have less experience with and show them how to effectively use those tools with preschoolers. Respondents of this study were students, 76 master's degree students and bachelor's degree students, and this experiment was set during their training at preschool educational institutions. And we had no chance to stay all the time at preschool educational institutions. So we observed students and we interviewed educators, methodologists at those preschool institutions, teachers and directors of those institutions. We interviewed them and surveyed them, and they gave us feedback on how effective were our students. As for the tool we designed for the pre-test, we aimed at building blocks of professional competence, and the professional competence was split into prognostic, organizational, evaluative, analytical, design, information and communication, pedagogical partnership. And in terms of these professional competencies, we developed 3 sets of criteria for cognitive criteria regarding the knowledge both of ICT and of how to develop social and civic competence. Activity criteria as being able to organize those activities and use ICT for those activities, and motivational criteria and attitudes of students towards developing social and civic competence using ICT. And we use descriptive statistics to identify the low, average, and high level of competence. And you can see the data on the slide. As far as one of our themes was to assess those ICT tools they have been already exposed to. So we identified that ICT tools used by students were Meet, Zoom, Padlet, learning apps, generally Flippity and Kahoot. However, some challenges students mentioned with other tools. And knowing that, we designed the intervention, the course. Let me present you the course. So this was a Child in Society course at Boris Hrynchenko University. It was compulsory course for pre-service teachers for 2 semesters. It was delivered in blended mode, and it ended up with a credit. It focused on both theoretical and practical expertise in socialization of toddlers and preschoolers with the goal of fostering social and civic competence through person-oriented interaction between adults and children. And the main tools and the main delivery was through Moodle and online teaching tools. And some of the modules which were built on the results of the survey and on the results of theoretical grounding we analyzed was early preschool children in modern education, socialization of toddlers and preschoolers, pedagogical support for the formation of social civic competence of toddlers and preschoolers, and well-being of children and teachers, effective tools and practices of psychosocial support. Within these modules, we collaborated with the LEGO Foundation and MHPSS, which provided us with some of the materials on developing students' competence. In terms of ICT in teaching this course, we delivered lectures using the following ICT tools. Seminars and workshops were delivered using tools students identified as a little challenging with. And we also used VR Zone IT Lab and STEM Lab in ICR class, which was designed and created at our university thanks to Erasmus Plus project. As I mentioned, the LEGO Foundation helped us with some of the materials so that student teachers can model activities using ICT for preschoolers. They worked on emotions of students, how to develop them. They designed calming corners for them in terms of developing and regulating their emotions. And they also designed various tasks for preschoolers in terms of they're developing their social and civic competence. And within this intervention course, they designed different projects. For example, developing social interactive environment for fostering socially approved relationships in preschool children. They designed how these activities and how these relationships should look like, and they were also framed like e-book for students, which the student teachers can use during their training. Also, 5 rules of teacher resilience. Sorry, and using Go Animate, GIF Animate class tools and other tools, student teachers designed their own flip books online so that they can present information in visual form, which is appealing to students. Also, there were projects like Give 5 and working on emotions of toddlers and preschoolers. It was based on the theory of Svetlana Zroy's ideas, and using ICT tools, student teachers developed these books on regulating emotions of toddlers and showing them appropriate ways of showing emotions in society. And also, these developed materials were used within their training. There was also electronic advent calendar for preparing students to some activities. It developed their patience, and it also fostered their social and civic competence. And the results of students' readiness to form the foundations of social and civic competence within the post-test are on the screen. You can see that the key competencies enhanced were prognostic competence, organizational competence, and information communication competence. Again, here on the chart, you can see the average data. We took the mean for surveys, for observations, and this text on the key competencies enhanced. This is an extract from the article where you can see the detailed data. Some of the practical implications of this study is the increased motivation of students to explore ICT tools and explain topics in child-friendly way. And the next one is raising the development of the ability to develop social and civic competence of toddlers and preschoolers, and raising the quality of teacher training in work conditions, because we observed how students were, first of all, collaborating on creating those projects, and this is the development of their social skill and building the community of support. And also, secondly, they fostered social emotional learning in their students. So this was a cascading effect for this research. Some of the limitations are limitations of the sample. We should admit that even though there are 76 students participating in this study, it was maximum we could afford in terms of our pedagogical practice. However, it's not representative of all the preschool student teachers in Ukraine. And limitations of the research tool, we should admit that we couldn't stay with student teachers at preschool institutions all the time. So that is why we had to design it kind of. Can you hear me? Okay, back to limitations. So the limitation of the research tool, we couldn't stay with student teachers all the time at preschool institutions. So that is why we had to kind of triangulate this. We observed their work for some of the time, and the rest of the time we involved those who work at those preschool institutions, directors, methodologists, and actual teachers. And also limitation of the surveying tool, as in any surveying tool, there might be some plausible answers and kind of like socially accepted answers from students. So we do admit that this limitation exists. Thank you for your attention and welcome to discussion.
Thank you so much for your presentation. Do you have questions? Yeah, okay.
Thank you for your very interesting presentation, and I have two questions. The first question is about type of competence. You told about social and civic competences, and I would like about, is it general or professional competences in your context?
This is about formation of social and civic competence of bachelors and how they would develop it in preschoolers. And we see this as a general framing on social and civic competence. It's more of what their responsibility is to develop in students. In terms of social competence, we worked on their ability to collaborate with others and organize collaboration of children, and also how their behavior should model the behavior students should acquire. In terms of civic competence, this is attitudes towards what is right and what is wrong, and what is socially accepted, and what are kind of like little laws for children they should model.
Thank you. And my second question is about your pre-last slide about competences. I would like to ask why did professional competences decrease after your experiment?
Sorry,
blue color
blue color.
bar plot.
Yeah, this is low level. Why it decreased? In terms of the mean data, it decreased because the others changed the average and high level. So it would be, well, it's kind of like we thought it if they had a low level at the very beginning of pre-test, then after our intervention, there are less people who have a lower level. And the survey observations and interviews showed that, yeah, that's a fact.
Thank you.
Any other questions? I have a question from me. Like first question about let's call it like ICT tools that you choose. You know that we have like tremendous amount of tools nowadays. It's like even not possible like to discover all of them. How did you choose like that exactly these tools they need? Like you need to ask students whether they know or not.
Yeah, excellent. Thank you. I guess I didn't mention that. So when the survey tool was designed, there were some semi-structured survey. So we gave them some options on very typical tools we expect them to use. For example, for online video conferencing like Google Meet, Zoom, or Microsoft Teams, and they had to tick which of them they feel confident enough using. And also we gave some ideas for them of groups of tools they might use in according to our idea. And if we didn't see the tick there, then we realized that they don't use it. And there was also an open question, like what tools you feel challenging using in terms of like using in educational process or with us during our classes. So they could add their own e-tools. And after analyzing the data from the survey, we realized ICT tools which they already feel confident with using, and those which we added and they added were grouped into one big group, challenges.
Okay, maybe I didn't understand like everything, but if it's like they can add tools like in the survey, so you can't measure another students according to this, like whether they have like any challenges with this tool because it's not inside the survey. Like
they self-identified what challenges they have with tools.
yeah,
they could also add tools they had challenges with. And after that, we designed the intervention course.
I mean, for example, I mentioned in this survey that I have some troubles with ChatGPT, and you didn't add it to the survey before. And you don't know about other students, whether they have like problems with ChatGPT with this survey, because it's like creating like on the, you know.
Yeah, I get your question. Yeah, so even though some of them might have no challenges with, let's say, ChatGPT, there are some activities with ChatGPT here. So regardless if they have challenges or not, they could be exposed and see it as a tool which they can use with their toddlers.
Okay. Another question about your sample. You have this like that you had 76 students. Students, it's in higher education, like
yeah, exactly.
Like, but then you have this split and only 7, 21, and 7, so it doesn't combine to 66.
Yeah.
Maybe.
Okay, I guess that's a confusion of this chart. Let me elaborate on it a little more. So we had bachelor's and master's students, total 76. There were us, researchers, who observed them when they were in preschool institutions. However, we couldn't stay with them all the time because we had plenty of work on our plate. So we observed them. After that, the rest of the time, they worked at preschool institutions during their pedagogical training. And because we couldn't see what's going on, if they are successful in formation of that competence, we interviewed and surveyed educators, methodologists who worked at those.
Oh, okay. So
yeah, so it's
different people.
Yeah, right.
Okay.
That's what I mentioned about the limitation of the study. We couldn't stay during all the pedagogical practice with 76 students being in 7 various preschool institutions.
Okay, once we are here, so am I right that you measure self-efficacy
Yes.
as motivation? When you tell motivation, it's actually self-efficacy.
Yes, right.
Okay, and did you measure like significance of your results? So we see charts, some difference, whether it's significance.
In terms of motivational component?
In terms of like statistical one, like of course we have some difference after your training, but whether it has any statistical significance. Yeah, sorry.
Yeah, because we use different tools, it was a little challenging to address quantitative and qualitative data and to show its significance. So we chose descriptive statistics and you. Can you hear me? Yeah. And we used descriptive statistics to get these results because this is mixed method research. And that is why that was a confusion between all the data. So we decided to take the descriptive. What if I stand closer? No, it's work. I guess it's working. Thank you. Thank you.
Any other questions? Yeah.
Thank you for your interesting research. I have the following question. When we teach students, yeah. Okay. Programming, for instance, or math, yeah, we can measure their competences. If we just give them task and if they can solve it, then that's the indication. How can we measure competences in the future in the teachers to form competent social and civics competences in the children if we don't observe these teachers interacting with the children themselves?
Thank you for your question. In terms of how we measure it, like how it's possible, so we split the professional competencies into blocks, like prognostic, for example, being able to predict the results of organized activities for preschool children. And there are some indicators in the article for all of them, and they all fall into criteria: cognitive, like knowing, like the knowledge itself, and then activity, being able to do that, and motivational, and more about self-efficacy and how they feel about it. And altogether, it's about the competence. Did I get your question right?
Well, that's my question was knowing how to do something.
Yeah, cognitive criteria
is not the same as being able to do that.
Right, that is why we added the cognitive criteria and activity criteria and motivational. And then we tested, we observed, was that lovely chart? And that is why we observed how students do that. And because we couldn't observe them for a very long time at 7 different kindergartens, we used interviews and surveys to get the data how students do that. Yes, right. Yeah, with children.
Okay, thank you so much. Thank you again. Yeah. So our last but not the least talk of this part of the session is from Vitaly Koblitz from Kherson State University with talk Designing Academic Programs for Data Specialist, a data-driven approach using machine learning techniques and labor market data.
Thank you. So, dear Chair, dear participants of ICTERI conference, my name is Vitaly Koblitz. Let me introduce the research designing academic programs for data specialists, a data-driven approach using machine learning techniques and labor market data, prepared by our team, Olena Kuzminska, Maria Mazurchuk, Vitaly Koblitz, and Alla Tsapil. I'm very glad to take part in this event and share the results of our research. On this slide, you can see the structure of our presentation. Data-driven decision-making has become a strategic approach for business, government, organizations, and education due to cheaper processing costs of cloud services with data lakes and big data, including structured and unstructured data set. The use of labor market data has an impact on not only on the business, but also on education, where academic programs should meet the needs of labor markets. There is a constant need for training and retraining of data specialists. With the application of AI and machine learning, it's possible to make more accurate predictions and recommendations for students' learning path finder. The aim of the paper is to develop an approach using methods and models of machine learning based on the analysis of open data from labor market vacancies to formulate recommendations for students to build an individual educational path in the domain of data specialists. So the main tasks can achieve the above goal are determine and specify the requirements of the current labor markets based on existing vacancies. For example, for data specialist positions, this approach makes it possible to consider the needs of the labor market at the level of skills of the specialists rather than focusing only on job titles. Develop a model for predicting possible areas of professional development based on information about available skills, which will allow students to rationally design individual educational pathways, teachers to update academic programs, and candidates with the appropriate skills to more effectively identify potential career opportunities, and prepare recommendations for the design of individual educational pathways for students using a data-driven approach based on the results of machine learning of data set of in-demand skills. Today, data-driven decision-making in higher education is a part of university management, goal setting for academic programs, selection of educational components and teaching methods to improve student success in terms of program learning outcomes, analysis of learning models, dropout forecasting, increasing learning efficiency, and reducing administrative bureaucratic burden. However, most studies are based on educational analytic data what take into account the general and specific subject competences of applicants are based on data from education systems and platforms on survey of higher educational institutes subject area. Simultaneously, scholars have highlighted the limitations of educational analytics in data-driven decision-making as opposed to external data sources. In particular, the problems of using such methods include the unstructured nature of the analytical data, their considerable volume, and the difficulty of identifying timely trends in large educational data sets. At the same time, despite the development of general artificial intelligence in the higher education, the use of machine learning methods in educational analytics has not become widespread. This is confirmed by the results of recent research relevant to our topic, which focused mainly on two important areas. It's a technological area, studying the effectiveness of machine learning methods and models among data specialists, and educational area, exploring the potential use of machine learning methods to assess the correspondence between students' professional competences and labor market expectations. To the best of our knowledge, machine learning methods are not used in the development of academic and training programs for future specialists. So the next slide concerns to research design, and research design includes open data set, data engineering job posting, which includes more than 6,000 vacancies in 2023 from Kaggle resource, and 3 main stages. Stage 1, methods and cluster analysis, which contain method of k-means and principal component analysis. Stage 2 is a method XGBoost, and stage 3, selected components of the Information Systems and Technologies bachelor degree program at Kherson State University. Distribution of requirements for the positions of data scientist, data engineer, data analyst based on 6,025 job vacancies and a set of 20 top skills demanded by IT components. From the data presented in these bar charts, it's clear that from the perspective of employers, shortly, data scientists place a high priority on skills on Python, SQL, machine learning, and R. SQL, Python, Amazon Web Service, and Azure, and data engineering skills are key for data engineers. And SQL, data analysis, R, and Python are commonly required skills for data analyst positions. Specific skills such as Python and SQL are common to all 3 positions, while others such as machine learning, ETL, knowledge of cloud platforms, or data processing are role specific. This suggests that candidates can increase their chances of successful employment by improving these skills, what are most in demand for their target position. Based on the analysis of this top list of skills, we can conclude that each position requires basic training in programming languages and environments such as SQL, R, Python, and Java, data analysis and modeling, and data engineering, knowledge of cloud platforms such as Amazon Web Service and Azure, data processing tools such as Kafka and Snowflake. However, as the labor market often contains overly specific requirements in job descriptions, such as redundant skills that are not essential for the role, their job titles don't have a clear link to the skill set, we conducted a study using cluster analysis. Our primary objective was to categorize job vacancies based on the most relevant skills. 5 clusters were identified, each representing specific skill sets required for different specialization in the domain of data specialists. The distribution of vacancies in these clusters was prepared by the means of principal component analysis and modified k-means, which best meets the needs of clustering binary coded data. So, the distribution of data specialists' skills by cluster we obtained as follows. You can see cluster 0, database engineers with SQL as a predominant skill. Cluster 1, data operations engineers reflecting strong ETL and database skills. Cluster 2, data analysts emphasizing data visualization and analytics capabilities. Cluster 3, cloud data engineers highlighting expertise in cloud services and platforms. And cluster 4, data scientists distinguished by advanced proficiency in Python and machine learning. So, the names of these positions not only captured the characteristics of the clusters, but also outline potential career paths for data specialists. The cluster names are derived from the prevalence of skills that define the professional identity within each clusters. On this slide, we illustrate the workflow of developing our predictive model, focusing on splitting our data into training and testing sets in 70/30 ratio, which is a common practice for machine learning models, to ensure generalizability and to avoid overfitting. For the predictive modeling, we used the XGBoost classifier algorithm, which is well known for its high performance in classification tasks. To optimize the model, we applied randomized search cross-validation, which helps find the best set of hyperparameters by testing a wide range of values in a randomized way rather than testing every possible combination. This speeds up the process and is often effective for complex models. On the next slide, we can observe two key aspects, feature importance and confusion metrics for multi-class classification. Top 5 important skills for all roles of data specialists were revealed by XGB classifier and randomized search CV methods, such as Python, 19% of importance, SQL, 12%, data engineering and R each on 9%, and Tableau 7%. This insight allows us to understand which skills most significantly contribute to the prediction of specific educational paths. Accuracy we estimated based on confusion metrics. This confusion matrix is generated for multiple classes, for our 5 classes from 0 to 4, representing different clusters of educational trajectories. Each cell of the matrix shows the number of correct or incorrect predictions between the actual and predicted classes. The classification report presents precision recall F1 score and support for each class. The model shows excellent performance with a macro and weighted average accuracy of 99%, indicating its robustness in distinguishing between multiple educational trajectories. The model achieved an accuracy of 99.53% on the training data, and when evaluated on the test set, the accuracy remained consistent at 99.42%, demonstrating the robustness and effectiveness of the model in predicting educational trajectories based on student skills. In order to make a match between the skills and technologies required on the labor market and the program competences, learning outcomes, and educational components, it's necessary to make the following match metrics in the following order. First, match the skills and technologies, for example, for data analyst position with the professional competences of the academic program. Second, establish the correspondence between program learning outcomes and professional competences. And third, at the intersection of professional competences and program learning outcomes, identify elective components that ensure the formation of relevant competences and are measured by the relevant program learning outcomes. The most popular technologies for the data analyst cluster are Tableau, R, Power BI, data visualization, and data analysis. Based on the results of the matching of technologies, professional competences, learning outcomes, and elective components for the data analyst cluster, we obtain the result in the presented table for the bachelor degree program in information system and technologies at Kherson State University. The following table summarizes the list of professional competences and learning outcomes required for the position of data analysts. The list of different educational components as an intersection of corresponding program competences and learning outcomes will form an individual educational pathway for learners who plan to prepare for a data analyst position. So, the research demonstrates the application of data-driven decision-making in the educational process to prepare recommendations for the design of an individual educational pathway. After training and testing, the model demonstrated high accuracy, 99.53%, in classifying an applicant to one of the 5 data specialist positions, such as database engineer, data operations engineer, data analyst, cloud data engineer, and data scientist. The developed model was used to recommend elective components for the formation of an individual learning trajectory for students of the academic program information systems and technologies at the bachelor level of Kherson State University, Ukraine. Thank you very much for your attention. I will be glad to answer your questions.
Thank you so much. Any questions?
Thank you for your very nice presentation. I have one question. Am I right that your model has a lag of 4 years?
This model was constructed on the data of previous year, 2023.
But you designed the curriculum for students that start learning today, for instance. So they will graduate in 4 years. Do you believe that these requirements, these qualifications that you identified as crucial today will be still crucial in 5 years?
Thank you for your good question. In this case, it's a good initial point. So to design a new educational program or substantially upgrade existing one, we need to connection with labor market, and we have some normative competences and program learning outcomes, and taking into account requirements of labor market, we can to create a unique program which includes real requirements for future graduates of this program. So as initial stage, it's an important for us to take into account existing open data for this scientific and educational direction. And after that, we can each year to revise our program, taking into account new trends.
Hello.
Hello.
So I want to follow up on Rostislav's point. So you've done what appears to be a very thorough and very competent study. I'm just very concerned about a particular point. So I've done consulting work in data science over the last 15 years. And in my experience, data scientists who are the most successful are the ones who have basic fundamental understanding of data structures, linear algebra, etc. And it is my worry that you are sending, with apologies, exactly the wrong message. Do you understand what I'm asking?
Yes, thank you so much. In this case, yes, we have some difference between requirements of educational program and requirements of labor markets. In case of educational program, the requirements cover not only practical skills, but also theoretical ones. And in this case, educational program is based on the strong mathematical courses, which was fundamental to effectively use some skills and technologies. And in this case, we take into account 2 parts. From our point of view, we high educational institute can propose good theoretical base as MVP, for example, for some IT product. But to construct an interesting program for final users, we need to take into account practical skills, for example, for 3rd and 4th courses for our students. And these requirements can, in our opinion, to enhance our educational components for future specialists.
A very quick follow-up. I don't want to be argumentative, but I would submit to you that any attempt to run programs like that will always lag behind. I think Rostislav made this point very, very clearly. If you teach the students fundamental skills, the types of little tricks you describe, they can learn in a few weeks or less. But if they don't have the fundamental skills, they're not going to last on the data science labor market.
Yes, I agree that we consider job vacations, and in job vacations, as a rule, there is no requirements to mathematical skills, but in first case, it was professional skills, technologies, and in this is difference. Thank you.
As yet a follow-up to Alex's and Rostislav's questions, I would like to share my own experience with the database class, which is essential for data analytics and data engineers. So many of the students, when they submitted their feedback, said, you know, Guy, the class was too much theoretical. We're not interested in that. We're looking for practical skills just to go to the company and do our work. I do share wholeheartedly what Alex said, that those people have no future because they're inherently lacking behind by looking at the technologies developed 5 to 10 years ago, which are in practice in the companies. So the question comes, wouldn't it be better and more reliable and even more effective for future students to make this study by combining a data set coming from the resumes with the data on the most, well, popular or required or demanded courses in the selection of top universities worldwide? I mean, data science and data analytics. Wouldn't that give you a more balanced estimation of what could be a requirement for a data engineer to 5 to 10 year horizon?
Thank you so much for your question and recommendation. In this case, I think that top courses in Coursera or Udemy can support to preparing specialists in data scientists, because students of high courses, they mostly know what they know and which position in labor market would like to have. And in this case, it can fill the gap between the requirements of labor market and preparation in high educational institutes. In this case, it can be as, for example, informal courses or part of elective or mandatory courses, when we can take into account, for example, certificates of the students, for example, to cover some credits in professional-oriented disciplines. Thank you.
Will you allow me a very quick follow-up? In my opinion, you are not talking about the skills. You have listed instruments. Do you understand the difference? And instruments change very quickly. And you have not made the core of your analysis the actual skills. Okay, so what you have said about market labor is the task of professional schools, not universities. I'm sorry.
Thank you for your comment. I think that in this case, we have I agree, very many instruments, but in this case, skills to use these instruments, for example, can be formed on one of them. And after improving such instruments, the switching cost to use new instrument is smallest than for beginners, for example. So in this case, we can consider these instruments as initial point, and after that, we can use the skills for analogous instruments more quickly.
Thank you. Any other questions? I guess. Thank you again.
Thank you.
We have coffee break. We can stop for here and have coffee break before the next session. Thank you today.